All right, let's jump right into this explainer. We're looking at how Grok 4.5 is basically rewiring AI-augmented engineering. We are officially moving past simple chat interfaces and stepping right into the era of autonomous, multi-step coding agents. But, as a lot of you already know, scaling these systems is notoriously difficult. So today we're breaking down exactly how xAI's newest model solves the biggest headaches in agentic coding, how it stacks up against GPT 5.6 Sol, and how you can architect your systems for maximum ROI.
Chapter 1. The Agentic Coding Bottleneck. Look, we all know the absolute dream here, right? You hand your AI agent a Jira ticket, and it just seamlessly writes the code, runs the tests, and submits a pristine PR. But in production, why do these agentic loops actually fail at scale? Well, it usually comes down to the multi-step problem. As your agent grinds through a code base, these tiny early reasoning errors, they start to compound, and eventually, it leads to total task drift.
Here's how that failure cascade actually plays out. You start off fine, fetching context, moving into reasoning, but man, after a dozen or so tool calls, the model just completely loses the plot. The context window gets totally jammed up with old error logs and previous tool outputs. Suddenly, the model is hallucinating a function that literally doesn't exist. It forgets the original instruction entirely, and the whole thing just crashes. It basically gets tangled up in its own intermediate steps.
And here is the ultimate bottleneck. A failing 15-step agent loop that can leave you sitting there waiting 5 to 9 minutes just to get back a broken, tangled mess of an app. I mean, in a high-volume CI/CD pipeline, burning nearly 10 minutes just to hit a brick wall is a massive productivity killer. You just end up with this code that looks like it was frantically stitched together at the last second, rather than properly architected.
Chapter 2. Enter Grok 4.5. So rather than just throwing more parameters at the wall, this mid-cycle frontier model from xAI was engineered from the ground up specifically for multi-step agentic coding. Trained out in their massive Memphis data centers, Grok 4.5 is designed to fix that task drift we just talked about. How? By making way fewer unnecessary tool calls and actually sticking strictly to the original plan.
And honestly, the raw specs here are super aggressive. We're talking a massive 500K context window and some seriously competitive pricing. $2 per million input tokens. To put that into perspective, when your agent is making 30 different calls to resolve one single issue, this kind of price drop doesn't just save a few pennies. It fundamentally transforms an experimental prototype into a highly viable production tool.
Chapter 3. Inside the Architecture.
Now, a smart model is great, but it's really only half the battle, right? Your API infrastructure absolutely has to prevent latency. So, to stop that task drift, the system leverages something called context compaction. Think about it. As your agent iterates, it's spitting out a massive trail of text. Context compaction dynamically compresses all that history on the fly. It keeps the critical instructions, but intelligently dumps all the noisy garbage.
At the network level, this whole thing relies on sticky routing. By dropping in specific headers, like prompt_cache key and x grok conv ID, your requests get pinned directly to a single server. So instead of your data bouncing randomly across some massive global cluster, your requests are hitting the exact same machine where your giant codebase context is already sitting there, warm in memory. And guys, this is the absolutely crucial takeaway here. If you don't route this correctly, you miss out on that 50-cent cache token rate, and you're paying the full $2 every single time. By just adding that one header to your API calls, you're slashing your input costs by 75%. For high-volume agentic pipelines, failing to implement this basic architectural practice is literally just setting your cloud budget on fire.
Chapter 4. Real-world agent performance. Okay, so how does all this actually translate to your terminal? Well, on the super rigorous SW Bench verified coding standard, Grok 4.5 is scoring in the high 50s. It is confidently navigating real-world GitHub files and writing passing patches for complex, undocumented enterprise codebases, which, places it right up there alongside the absolute best frontier models available right now. But speed is where this thing really shines. Because of its incredibly fast time to first token and those really concise tool calls we mentioned earlier, Grok slashes the execution time of a 15-step loop almost in half. We're talking 3 to 6 minutes compared to the 5 to 9 minutes you typically get with the competition. It just gets right to the point. It totally skips that chatty, verbose preamble that other models love to spit out before they actually run a function.
Chapter 5. Grok 4.5 versus GPT 5.6 Sol.
Look, we can't do a deep dive on Grok without talking about the other heavyweight in the space, OpenAI's GPT 5.6 Sol. If we just look at the raw network data, GPT 5.6 Sol does push slightly faster raw throughput and lower latency. But Grok makes up that ground in tool call efficiency. Sure, Sol might generate tokens a bit faster, but Grok requires fewer tokens overall, and fewer total steps to actually get the job done.
Because of this, their use cases naturally diverge. Grok is an absolute beast for high-volume, cost-efficient iteration. It generates concise code with zero fluff. GPT 5.6 Sol, on the other hand, really shines when it comes to deep reasoning, extensively explaining its logic for code reviews, or finding those subtle bugs hidden deep inside massive 100K token codebases. So if you want a fast prototype, you use Grok. But if you need a deep, methodical security audit, you're probably going to lean towards Sol.
And of course, we have to talk about the budget. Ultimately, GPT 5.6 Sol is running about 35 to 40% more expensive per task. And man, that is a penalty that compounds massively at production scale. If your agents are running hundreds of times a day across a whole team of developers, that cost difference alone can literally make or break the viability of your internal AI tooling.
Chapter 6. Building with Grok.
But here's the secret. You don't actually have to choose just one model. You want to architect a system that gives you the best of both worlds. By using platforms like MindStudio, you can actually build a routing layer. You route initial repository scans and fast scaffolding straight to Grok 4.5. But if the agent suddenly detects a complex architectural conflict, boom, it automatically escalates the task to GPT 5.6 Sol for that deep reasoning.
And the best part is that implementing this is incredibly easy. Since XAI uses OpenAI-compatible endpoints, you literally just swap out the base URL and the API key, and you can start testing this immediately. Just remember the golden rules, maximize those caching headers to hit that sweet 50-cent mark, rely on Grok for your rapid prototyping, and definitely watch out for mid-context retrieval limits when you're dealing with truly massive files.
So we've seen how Grok 4.5 brings some pretty unprecedented speed and cost efficiency to agentic coding loops, and how it perfectly complements the deep reasoning of models like GPT 5.6 Sol. With these massive new leaps in performance ready to go with a simple API swap, the only real question left is this: how are you going to architect your next AI-augmented engineering team?